Hello, good morning, and a very warm welcome to Breakfast with Arup. A very happy new year to you all. It's great to see you here. I hope that Christmas is not too long a distant memory and you're all still feeling suitably rested, notwithstanding the grey rain yesterday, coupled with the joys of a tube strike. Anyway, here we all are. My name is Farah, and I'm the Marketing and Communications Leader for Buildings London. And so to our speaker this morning. Andy was born in Stockport in Greater Manchester. His father was an engineer and worked on marine gas turbines and jet engines for military aircraft. By the age of 15, Andy was convinced that he would become anything other than an engineer. Being dragged into various factories, he thought that engineering was dirty, smelly, and being covered in oil. His original plan was to be a geologist or a meteorologist. However, the sixth form timetable was mixed up, which meant that Andy could not study geography. Instead, he went on to study physics and maths. Andy decided he would quite like to attend Cambridge University, as you do, and his plan was to gain entry through engineering, then change subject to something more interesting, such as history of art. However, he did not make the change and studied a degree in engineering. In his final year, he took mainly mechanical papers. At Cambridge, Andy was involved in a number of environmental groups, with particular interest in renewable energy and the anti-nuclear movement, hence the photograph behind me. One day in the library, he found a book called Building Design for Energy Economy by Arup. This duly inspired Andy to look for a job here with us. When Andy applied for a job, he was told that an electrical engineer would at that time earn £500 more than a mechanical engineer. So he joined as an electrical engineer. I then did ask, out of interest, how much a salary was back in 1983. £6,000. There you go. Starting his career with Arup in 1983, he joined a group led by Tom Barker and Peter Rice that was working on the Lloyds Building and the Menil Connection in Houston, Texas. As well as a career as a building services engineer, Andy has also developed expertise in the lighting and daylighting of museums and is preeminent in this field. And as such, Andy was made an Arup Fellow in 2006. On the recent completion of the Broad Museum in Los Angeles, Liz Diller of Diller Scofidio Renfro said, "Andy Sedgwick is the premier daylight engineer in the world." And on that modest note, I'm delighted to introduce the occasionally charming Andy Sedgwick, who will remind us all of when we were young. Thank you, Andy.
Thank you, Farah. Wonderful introduction as usual, and thank you all for coming along this morning. When I was preparing for this talk and agreed to this title in particular, I thought I might be channeling a rather whimsical children's book by the author of Winnie the Pooh. Or perhaps more relevantly, a film by Ben Stiller dealing with the midlife crisis of a professional metropolitan. But I should have known that Farah's choice would be a song title. So here I am, lip-syncing to an Adele song that I've never even heard. I'm going to start with a couple of anecdotes that are only about 100 yards apart spatially, but over 20 years in time. When I started in Arup in '83, one of the first projects that I worked on was Lloyds of London. My first package was the exterior lighting. I worked on the roof with Graham Stirk, and in the lower ground floor with Ivan Harbour and a young Amo Calzi, all from Richard Rogers and Partners. Now, down in the low ground floor, we quickly chose a marine-grade aluminium fixture from Denmark, which would work well with the overall Lloyds aesthetic. There it is today. I thought my bit was doing the calculations, and these were relatively straightforward, to work out what light levels we needed and hence the spacing of these. But actually the complicated part was working out how to bring an electrical feed to each of these, through all the complex retaining walls around the perimeter of the site, through the granite set finishes and so on. There's plenty of power downstairs, but getting it up through the external works was complex. In some places, we needed to use exposed metal conduit, galvanized steel, that protects the electrical cables when they're out from damage, and they give you a way of rewiring in the future. Now, to my amazement, AMO wanted to know everything about the conduit system we were going to use. What the possible range of materials were, what the diameters, what the bending radius would be, how often does it need supporting, what type of saddles can we use, what type of screws go on the saddles, every little detail. He wanted to understand and draw everything. Every conduit run was drawn in plan and elevation, and many three-dimensional sketches filling in the detail. I was really taken aback that an architect would want to understand every detail of such a dull engineering system. And more importantly, it meant I had to do all this research before I could give him the answer. So I owe the in-depth knowledge I retain to this day of fascinating conduit and trunking catalogues to this man. Now, forward winding a few years and jumping from the micro to the macro, I found myself working again with Graham Stirk, this time on the initial iterations of the design that was to become the Leadenhall Building, literally across the road from Lloyds. Although both are predominantly office buildings, one was built for an owner-occupier and the other was a speculative development to be occupied by tenants yet unknown. The wedge-shaped form of the building was driven by consideration of this key view of St Paul's. An obvious consequence of its wedge shape is the offset core, the only place where lifts and stairs and other services could reach the top of the building was on the northern side. Now, the building needed 3 banks of lifts, 2 goods lifts, 2 fire stairs, toilets, an air conditioning system for each floor, all to serve these future tenants. And for a while, we were struggling to find the right arrangement. It was difficult to meet the net to gross requirements of the developer, and the wall to floor ratio with the multiple lift cores that we began with was getting the thumbs down from the QS. It just wasn't stacking up as a viable floor plate. I remember one key meeting when we hit upon the concept of a single core with all 22 lifts located across the full width of the site. This is the developed version of that same plan, with the high-rise lifts on the right, the medium rise on the left, and the low rise in the middle. And the black squares are the goods lifts. In the blind shafts of the high-rise and mid-rise, we can put the toilets on the lower levels, and then these jump across as the different lift banks become active. And finally, we squeezed the air handling units, a supply and a return, into these cupboard spaces on either side of the core. This move created a whole additional bay of office space, and we were rolling. Although there were still 12 years to go, the power of a great diagram like this core stands the test of time throughout design development and the construction period, and it's legible to both lay and learned eyes in the final design. Now, I think these 2 examples, the micro, the conduit design at Lloyds, and the north core at Leadenhall, are 2 examples of a design methodology known as systems thinking. It's a methodology that seeks to understand, optimize, and then organize all the components of a complex system. It's often used in other disciplines. It's used for designing businesses and the architecture of IT systems as well. In the world of buildings, it's particularly synonymous with the high-tech school of architecture. This really began in the 70s, 80s, when there was a growing frustration among many building professionals about the glacial pace of technological development in the construction industry. This was at a time when we were still putting people on the moon, and when the automobile and aerospace industries, as well as the computer industries, were using new materials and new forms to rapidly evolve high-quality, highly reliable products assembled in new robotic factories. By comparison, construction seemed mired in messy, wet trades. And these required large amounts of labour on congested and poorly organised construction sites. So one of the goals of the high-tech approach was to move more production off-site, and we saw the emergence of things like toilet pods and air handling pods that could bring a whole complex sub-assembly to site and plug in. One second key idea often used in the high-tech approach is the concept of the servant and the served. I think this is Louis Kahn's original statement that you should keep the part of the building that people use as straightforward and uncluttered as possible. So the Lloyds floor plan is a simple rectangle of usable space with an atrium in the middle. And around the perimeter are all the satellite service cores that provide the services, the vertical circulation, and the toilets. The square in the middle remains completely free for its intended use. Linked with this is a goal of renewability, a recognition that building components have different lifespans. And by putting services and other systems outside the occupied zone, they're more readily reconfigured and updated. That's the theory anyway. Now, the high-tech movement, or school of architecture, really was a London phenomenon, surprisingly perhaps, that began in the 70s. Some people have described it literally as the body of work by Richard Rogers, Nick Grimshaw, Michael Hopkins, Norman Foster and their firms. There are sporadic examples in other places, but it's primarily a London phenomenon. And so one question is, why London? The architectural critic Colin Davis has suggested that one enabler of the high-tech approach in London was the availability of engineering advice of the highest quality. Engineers such as Frank Newby, Felix Samueli, Tony Hunt, and Arup, and all his august partners, were here and ready to engage. And for those engineers, this was a great opportunity to fully engage. Some high-tech architects have said that they can't really make a start until they've had a formative conversation with an engineer to understand what the building really wants to be in terms of its technical form. For most engineers, this was quite a refreshing opportunity compared to the days when they would basically draw the structure and the services on after the architect thought they'd more or less finished. Now, the high-tech approach is most closely associated with things like these expressed steel structures. And many of the primary examples use steel in tension to create very lightweight enclosures. But the growing complexity of systems within buildings and the oil crisis of the early 70s put much greater emphasis on the planning and performance of building services within a high-tech building. And we saw building services engineers, such as Tom Barker here and Max Fordham, being invited to contribute to the formative stage of projects, not simply as they finished detailed design. And projects like Centre Pompidou are real graphic essays in the application of system thinking applied to services as well as structure. I think this way of thinking led to a feeling of a shared endeavour between engineer and architect, with a number of shared goals. The first is a belief in technology and a belief that we, the design team, can harness it to create a better environment. In France, Peter Rice's understanding and exploration of glass technology helped create a new architecture of transparency and lightness. At the Louvre, this included the two different glass pyramids that made the most of new nonlinear analytical techniques and methods of fabricating and fastening glass. And in environmental design, growing computer capacity meant that airflows and light distributions could be accurately predicted in early design stages, leading to buildings like the Kansai Airport Terminal in Japan. Here, the form of the roof was primarily generated through an understanding of the trajectory of a cooling air jet that serves the whole of the upper concourse level. That's over 90 meters across. And this approach was really only possible because of the growing computer capacity and analytical skills we had to analyze every sort of pocket of air within that space. We could understand simultaneously its temperature, humidity, momentum, and direction. And over a week of computation, we could forecast where the air wanted to go and then wrap our building around it. At the same time, the high-tech approach embraces the industrialization of building production and often wants to push the boundaries of current construction practice. As Peter Rice points out in his book, An Engineer Imagines, when industry resists a new idea, then the engineer has a special role in the design team to withstand these arguments and demonstrate the wrongness of the industry's position. And in this scenario, the engineer becomes critical and can save his soul. Possibly. A second shared goal, function and efficiency. One of the tenets of high-tech is that really every design decision has a functional justification. We don't just, things just don't appear in the design. One example I'd like to share here is the roof design of the Art Institute of Chicago, because it follows this principle. The components of the shading canopy above the third floor galleries, which is known as the flying carpet, it's designed to keep all direct sun off the gallery skylights beneath. Every dimension of this shading system has been honed to the minimum by technical considerations. The solar geometry, ice formation, and wind-induced vibration. This is one of our most senior acousticians working out the natural frequency of the structure by the age-old method of hitting it hard with a hammer and listening to the sort of bong it made. In skillful hands, these elements become iconic parts within the overall building form. They become one of the signature architectural pieces, whilst also being completely functional. Every piece is necessary and just sufficient for the job it needs to do. But the ensemble together creates a rhythm of light and shadow that requires no further embellishment. A third and sort of linked goal is about legibility, all the way from a concept diagram through to the finished form. This is another Renzo Piano roof, this time at the Baylor Foundation in Basel. These are the very first sketches created on air sickness bags from one of Renzo's flights. And it shows the beginning of the evolution of an idea of a layered approach to the roof design. This sketch on the left shows those different components. There's an external glass brise-soleil that keeps off the direct sun, a skylight beneath that keeps the weather out and also absorbs UV radiation, and then some motorized blinds that regulate the light before it reaches the ceiling of the space, which is formed by perforated metal sheets with a paper insert. So each layer doing a defined job and being legible in the way it does that. Here's that section developed into a working drawing, and then we see the components in the final building. And from afar, those brise-soleil become a key character of the finished form. Even inside, you can just about make out that that ceiling isn't completely diffusing. There is a view through, a feeling of depth and an ability to read some of the layers above and to figure out how it works. Now, on to the dangerous bit here. Of course, there are many other valid design approaches to architecture. Explorations of fluidity, parametricism, and the emotional and social responses of different building forms. Many of these pose interesting and demanding challenges for engineers as well. It can be very engaging to learn a new language and a new aesthetic with a new architect. But somehow, often the goals are more rarely aligned. The engineering diagram becomes forced and can be distorted by other factors. Or, as the engineering becomes hidden away again, it can become banal, perhaps efficient and rational, but no longer celebrated in the completed form. The engineering expression is subsumed to a different, although quite possibly much more important, agenda. As Peter Rice a little mischievously said, when one works with different architects, then each architect's attitude and opinions become part of the problem that we need to solve. It's one way of thinking about it. London has been a great high-tech playground, both for projects, but also a place to do projects from over the last 30 years. And it's been a great place to learn the trade of building engineering. Just as it was said that the high-tech flourished in London because of the availability of great engineers, I think the converse is equally true. Working in this domain has developed a new and strong generation of engineering talent in London. People such as Chris Wise, Jane Wernick, Hanif Carr and Patrick Bellew. And of course, dozens, if not hundreds, of people here at Arup. So whether it's the search for the perfect engineering diagram to inform the fundamental form of a building, or gaining an understanding of minutiae of a conduit installation, most of these engineers have grown up with and been educated by this systems thinking frame of mind. My final observation is about the value of long-term relationships. I feel privileged to be working today with many of the same architects, and for that matter, QSs and project managers I began with when we were young. It's a pleasure and a continuing education to work with people you like and share a mutual respect with. But there's also an efficiency, a shared vocabulary and back catalogue of successful solutions and approaches that can speed things up and allow each project to be incrementally better, or at least educated by, the ones that have gone before. So, just 2 weeks ago, I'm still engaged in this dialogue, still learning from the greats. My final thought is that as we work in so many different ways now as design teams, we should try and rediscover a shared endeavour that was clearly there in those days from the high tech. We all headed in the same direction. It's not to say it's the only agenda. There are many very valid, different design agendas. But when we can all either rediscover or create a new shared endeavour with goals we can all communicate and understand to one another, then we're in a good place. Thank you very much. Any questions, please?
In the next 20 or 30 years, what division of engineering within Arup do you think will be the most exciting and growing division or department?
I think that some of the obvious challenges that we face now and the types of shared endeavour that are coming to the fore are obviously around response to climate change, designing buildings that minimise impacts on their environment. Another big agenda is the digital one. The way we work together is evolving, and the way we make buildings is changing too. And there's a possibility that some of our product will need to become more and more refined as perhaps machine intelligence begins to deliver some of the more straightforward buildings in a almost effortless manner. So I think digital and sustainable design are here to stay. For Arup, the field is very broad. We're seeing great growth in infrastructure projects as well as buildings. So although my talk's very much being focused on the building environment, the built environment more generally is getting a lot greater attention now and a lot more applied intelligence. Richard.
Yeah, Richard Hyman's in studio. Do you think, the fusing of kind of architecture and engineering, which is what the most successful examples of buildings you showed are, do you think there's a bigger step that needs to bring construction into? Because I'm of the mindset that we need to move another step forward and create a greater collaboration, rather than just architects, engineers, but architects, engineers and manufacturers, in order to really bring this together.
I think that's a great point. And as I remember from the designing in the 80s, it was largely architect and engineer. We now have as well a whole raft of specialists whose intelligence is also brought to bear. But we still have a sort of two-speed relationship with manufacturing and construction. They are potentially our friend. They are potentially the answer to a lot of what we need to do. But often the dialogue is still quite fraught. And as Peter Rice said, sometimes we have to try and come in with sort of a force of argument to make things happen. Getting that engagement early enough and understanding, it requires us to understand the processes of manufacture and construction, so that we know who to bring in at the earliest opportunity. Yeah.
Just leading on from that question, actually, you gave us the two great examples of Lloyds next to Leadenhall, and that relationship with the contractor. Do you think procurement has affected that relationship? I mean, I'm imagining that every single sort of nut, bolt and screw of conduit on Leadenhall may have been through a sort of D&B contract, and how that may have influenced the design process.
Good point. I'm just trying to... So Lloyds was constructed under the old, what was it called? Management contracting, Bovis, and which sort of evolved into construction management. Leadenhall began as a construction management project, but became design and build. I'd say for Leadenhall, one key factor was that switch to design and build was quite late on. So it allowed the design team to sort of largely finish the development of their design process and to get all the key components properly aligned. It did bring many advantages to have Lang O'Rourke on board, and in many ways we could have done with it a little bit earlier. The idea of bringing in precast concrete floors was a big innovation, and saved a lot of time in construction with no adverse effect on the aesthetic or the engineering functionality. So there are very much pluses to the if it's done in the right way. Design and build can bring a lot of construction expertise to the fore that can make a better project.
Well, it was great to see him and great to see his talk and see how things have developed, or actually not developed. In a way, some of the good things are still the same as they were 20 or 30 odd years ago. And I think what's great is that this importance of working together is as important now as it was 30 years ago. And what's really key here is to have a shared understanding or a shared basis. And I think perhaps what was easier 30 years ago was that it had a sort of formal expression of high tech, that there was a clear visual form to go with the idea of bringing technology into architecture, that it looked technological. And form has become much more diverse now, and different architects have different ideas. And so maintaining that idea of collaboration, I think, is probably more difficult, but even more important now, that architects and engineers, together with the industry, which I think is the third key player, which isn't quite at the table yet, can continue to work together. I think that's I think, the main message for me for today.
Yeah, I thought it was a fantastic talk, great way to start a new year, it's a nice reminiscent look back, but also a really clear message in that what we need to think about moving forward. And I think what was really good about what Andy had to say was that I think the future, and I think he was hinting at it, is more about collaboration, closer working relationships, not only between architects and engineers, but architects, engineers and manufacturers. And I think the next move to really start to gel what Andy was talking about is to bring all those three together. I'll tell you a really fun little story. One of the slides that Andy showed was the toilet pods on the Lloyds Building. 1982, I think it was, when they were building them. My mum worked at the manufacturing company that built those toilet pods, okay? And as a kid, I was still at school, we all followed and chased up the M4, the first toilet pod to come out of the factory, because it was a new way of building architecture. And I was sat in the back of the car at the time thinking, what are we doing? This is really boring. We've got 200 miles following this grey box all the way down the motorway. And we watched it being lifted into place, and it was really exciting. And I looked at the building. This is before I even had a desire to be an architect. Little did I know the impact that would have. I've now just recently set up a new business to build off-site manufactured homes, which are doing exactly the same thing all this time later. So I was sitting there thinking, oh my God, this is a really amazing journey from my childhood to Lloyd's Building to Andy's talk to where we are now. So really exciting, really good.